and we are webinar on solving equations. Now I'm going to get right to my PowerPoint so that we can begin this session. All right, and you should be seeing my screen right now. So welcome to our webinar session on solving equations. Now I'm just going to introduce solving equations in a very simple step-by-step way. You solve equations. That means that there is an equation where you have a variable, and variable represents an unknown value. Okay, and just one variable. When we can solve for that variable and find out what the value of that variable is. So solving equations and solving for a specific variable, you have to do what's being done to that variable. And we'll talk about order of operations here in just a minute. Now, some of these kinds of equations may be more intuitive. In other words, some things you can do in your head if you're good at arithmetic or quick with very basic quick numbers. There is a number, and number one, there's a number that we don't know yet, that you subtract 6 from that number. Well, maybe in your head you'll go, okay, well, I know I go 6 up from 12, that's going to be 18, so 18 minus 6 is going to give 12. So that kind of thing you can pretty much figure on your own. 4 times some number is 24. Well, if we remember our multiplication facts, 4 times 6 is going to be 24. So something I really need to do, because I know in my head that 4 times 6 is 24. X has to be 6. Okay, so X divided by 9 gives me negative 3. So I know that there's got to be some number that when divided is going to give me a negative. Well, this 9 is positive, so X has to be some negative number to produce a negative result when divided. So 9 into what number is going to give me 3? Well, I know 27 divided by 9 is going to give me 3. So negative 27 divided by 9 is going to give me negative 3. These kinds of things we can pretty basically solve in our head. But as we did in step 1, what I did was I said, okay, there is a number that when you take 6 away, it gives you 12. And I said, well, I know 6 more than 12. What I did was add 6 to 12 and what X was equal to. So that 4 times some number is going to be 24. Well, if I divide 24 by 4, I know that's going to give me my 6. I know that there is a number that when divided by 9 is going to give me negative 3. So if I multiply negative 3 by 9, that's going to give me what X is, or negative 27. This is the very beginning of teaching you the steps of solving equations. You're going to kind of do what's in the equation backwards. Take a look at that. In just a couple modules ago, we talked about order of operations. There are rules how we, in what order we perform multiplication, division, addition, subtraction, and when there's parentheses and exponents. There are rules, and we've just kind of created this acronym to let you know that we need to do parentheses first, and then exponents, multiplication and division, and addition and subtraction. That's the order. And when you put together an expression, okay, when you are simplifying an expression, you're putting it together. And so we follow order of operations. The first thing we're going to do here is multiply 2 times 7, subtract 14 minus 3. And that's going to give us 11. What happens if we already know the end result? So that this value right here is 7. Well, we're going to reverse order of operations. We're going to unpack or undo what's been done to X. So we're going to do this in reverse. So we're going to add 3 first to both sides because we've got to undo subtracting 3. And both sides, because this is an equation, we need to keep it equal. And going to give me 2 times some number is equal to 14. We've got to undo multiplying that number by 2 by dividing by 2 on both sides. And so x is going to give me 7, which is what this number was up here anyway. So in order of operations, putting together an expression, we follow order of operations. When we are undoing an equation so that we can solve for a particular variable, we need to do order of operations in reverse. So if anything is being subtracted from or added to our variable, we undo that by doing the opposite. Whatever is being divided or multiplied, we need to undo that by doing the opposite operation. Now let's see what that looks like in a good example here. We have 10x minus 10 is equal to 17. We can do this in our head, but let's use the reverse of order of operations and undo what's being done to our variable. Okay, I see that 10 is being multiplied to x. X is our unknown value. And we're taking away 13, and that should give us 17. I don't know what this value is. We're going to undo what's being done by starting with what's being subtracted from our variable term. So the opposite of subtracting, or to undo subtracting 13, we're going to add 13 to both sides. I'm going to draw a line down through the equal sign just to show you where this equation is balanced. And just think about it like a scale or a balance. I'm not an artist, so please don't judge my artistry here. Okay, we've got a scale, and it has to be balanced. The left side has to be exactly the same height as the right side in order for the scale to be balanced. Well, add 5 pounds to the left side. In order to keep it balanced, I must add 5 pounds to the right side in order to keep this scale perfectly balanced. Same thing with equations. When we're solving equations, you have to do the same thing to both sides in order to keep the equation balanced. So when we add 13 to undo subtracting 13, this goes away. That becomes 0. So all that's left on the left side is 10x. 17 plus 13, or 30. Now, the last thing that's done to my variable is that it's being multiplied to this 10. 10 is called the coefficient of the variable x. It's being multiplied to x. So how do we undo multiplication? We divide by 10. But on both sides so that we can maintain our balance in our equation. 10 over 10 gives me 1. X is equal to 30 divided by 10 is 3. And your final answer. Now, how do I know that is the correct answer? Whenever you have solved for your variable and you get a specific value, you can always go back to the original equation and plug it in place of x and see if you have a true statement. So instead of 10 times x, I'm going to multiply 10 times 3 minus 13. And does that really give me 17? I'm trying to work here. I'm going to put these together. I'm going to use order of operations. So I'm going to multiply 10 times 3, which gives me 30. Mine is that 17. Well, I subtract 13 from 30. It does give me 17. So I balanced the equation, so I know I've found the correct value for x. So the cool thing about solving equations is that you can take what you found your variable to be and bring it back into the original equation and see if that makes your statement true. One. Now, x divided by 5 plus 6 is equal to 9. remember, we're going to reverse the order of operations by undoing what's being done to our variable. First, we have to get rid of adding 6. So we subtract 6 from both sides of the equation. Give me x divided by 5, or x over 5, that is equal to 9 minus 6 is 3. Now what's being done to our variable is that it's being divided by 5. To undo dividing by 5, to multiply both sides of my equation by 5. Because multiplying by 5 reverses or undoes divide by 5. So 5 times over 5, that's 5 times 1 will to 1. So we've got x is equal to 3 times 5, or 15. And finally, answer. You've got equations with variables on both sides. How do we handle that? Well, before solving, we only need one term in our equation that has a variable. So we get rid of one of these. It doesn't matter if you get rid of the 5x or the 2x. By get rid of, that means that you undo it. Like if I'm going to get rid of or eliminate this plus 2x, I'll do that by subtracting 2x from both sides of the equation. Get rid of one of my x terms so that I've only got the single term that has a variable in it. So 3x is equal to 6. Now it's a little bit easier to deal with. Now, in order to solve, I'm going to divide by 3 to get rid of this 3 and multiply to my variable. So 3 over 3 becomes 1. X is x divided by 3 is 2. So there's your final answer. You double check that by plugging 2 back into the original equation and see if you've got a balanced equation. 5, 2 is 10 is equal plus 4. And it's a true statement, so I know I found the correct solution for x. Let's try where that we've got variables on both sides of the equation. And work this one because in the previous slide, I got rid of the x term on the right side of the equation. I show you it really doesn't matter. We could still to eliminate this 4x by subtracting 4x both sides. Let's just get rid of this minus x. Now, you have remember in algebra, you always have to look at a term and take it with the sign that comes immediately before it. So we are subtracting x. Let's get rid of this x term by adding x to both sides. To both sides of the equation, we'll add x just to keep this equation balanced. It becomes 15 is equal to x. My only x term is on the right, but that doesn't matter because this is equal. Okay, so let's finish solving. 5x, we have to undo multiplying x by 5 by dividing by 5 on both sides. And b is equal to x, with the same thing as x is equal to 3. So which way you write it, 6 plus 4 is equal to 10, or is equal to 6 plus 4. We know that both sides are equal, so you can switch them around, and you haven't violated any mathematical rules. Now, if we have two variable terms, but they're on the same side of the equal sign. So here is something you want to write down probably in your notes. When solving equations, you always want to simplify before you begin to solve. Now, listen to me. Again, here's where the equal sign is. Here's the left side, the expression on the left side, and the expression on the right side. You have to make sure that both the expression on the left and the one on the right has been completely simplified before you begin to solve or eliminate terms. What do I simplify? You need to add any like terms together. You need to perform any operations that need to be performed on that same side of the equal sign before we start eliminating and solving for our variable. So in this example, we've got two x terms, but they're on the same side of the equal sign, which means we have like terms. I have a 3x and a minus 5x. There are terms that need to be combined. And find these like terms, 3 and a minus 5x, I get minus 2x. That side is already simplified, is negative 20. Start solving because I've simplified the left side of the equation by combining like terms. So I'm going to divide both sides by negative 2 to eliminate or undo multiplying x by negative 2. This is going to give me x on the left is equal to negative 20 divided by negative 2 is a positive 10. And so is your final answer. So we need to simplify before solving. Let's do another example. We'll simplify before we solve. This looks like a longer equation than what we've been looking at. Well, that's because the expressions on the left and the right side of the equation have not yet been simplified. So I have 6 minus 6x minus 3. Well, I have two constant terms, two constant numbers, 6 and minus 3. So I combine these before I begin to solve. I don't want to be right in and subtract 6 from both sides, because where do you subtract the 6? You have to simplify before solving. So 6 and with minus 3 is going to give me a 3. 6x. Now again, we have negative 25 and a negative 12. These are constant numbers that need to be combined. You combine negative 25 and negative 12, or minus 12, that's a minus 37. Each expression on the expressions on each side of the equal sign have been simplified. There are no like terms. There are no operations that you can perform right now. So what we'll do is we will continue in solving the equation. We need to eliminate one of these x terms. And I'll choose to eliminate the 4x on the right, just x over left. That's where we're used to seeing x. You just bring that 3 down. Equal to that becomes 0 minus 37. Now, happening to our x term. Well, this is a positive 3, since he's at the beginning of this expression on the left side. And he has no sign, we assume that positive. So to eliminate this constant number, we need to subtract 3 from both sides of the equation. When we do that, we're left with negative 10x equal to negative 40. Now sides by negative 10 to eliminate the coefficient, and we is equal to 4. Now, be careful of your signs. Some positive and negatives will trip you up and probably be the reason for most incorrect answers if we lose track of signs. So when you're subtracting 3 from both sides, remember, this 37 is already negative. Combine terms with the same sign. You add the terms and you use the same sign. We divide a negative by a negative. When you divide values that have the same sign, your answer is always going to be positive. So remember, keep track of your signs. Now, again, going with the idea of simplifying before solving. Now, in this case, we have distributing to do. We've got a 4 that's multiplied to the difference between 5x and 4. So you multiply to this difference. So we need to distribute the 4 to both terms inside parentheses before we begin solving. So times 5x gives me 20x. Minus 4 gives me a minus 16. Give us plus 4. He's not inside parentheses, so we multiply him by anything, and then just this minus 11 is on the right. And simplify before solving. I have a minus 16 and a plus 4 still on the left side of my equation, so I need to combine those. We'll begin solving for my variable. 9 plus 4 is minus 12, and equals minus 11. Now, all we do is one term with our variable, and we're going to undo what's being done to our variable. So 20 being multiplied to x, and then we subtract 12. Remember, we reverse order of operations, so we have to get rid of what's being subtracted first by adding it to both sides of our equation. 20x is equal to 1. Multiplying x by 20, we divide both sides by 20, give a nice fraction as a result. X is equal to 1/20. Yes. Answer. Let's do examples of using the distributive property, because an equation like this can be a little tricky. 16 minus the 6 and 7 on the left side. And that's 5x minus 3. Now we need to simplify the left side, because 16 minus this S7, we need to remove the parentheses before we start solving for x. Yeah. Well, we are subtracting this sum, but because we've got a variable and a constant number, we can't add these numbers first. So we'll subtract both things that are inside the parentheses. Deborah, did you say something?
Anything?
Oh, I heard somebody say something. Okay, so we're gonna distribute this minus sign to both terms inside the parentheses. So in other words, both of them will get subtracted. Since 7 is positive, he becomes minus 7. And 5x minus 3. Okay? Don't despair if there's not a number outside the parentheses. That just means you need to distribute minus sign to both terms inside parentheses. Now, two constant numbers, 16 and then this minus 7, when you combine them, that gives you 9. Minus is x minus 3. Now we have two x terms, so I need to eliminate one of them. Let's study over to the right side this time. So again, it doesn't matter if you subtract 5x from both sides, that's still going to give you the same value. If you do your steps correctly, it will still give you the same result for x. So we could just as easily have said, I'm going to subtract 5x from both sides and work the problem that way. It doesn't matter which x term you choose to eliminate. You should get the same result. It's 6x minus 3. Now we'll continue to solve for a variable by eliminating this minus 3. 12 is equal to 6x. Solving by dividing both sides by 6, and we see that x is equal to 6. And if you subtract the 5x from both sides, you should have ended up again with x is equal to 2. Something that looks a bit ominous. We can tackle this step by step. Minus 3 times 2 is 3, plus all of that on the left side is equal to 33. I see I've got parentheses, and I've got a 3 that's distributed. However, I've got 2x minus 3. We're subtracting a product of 3 times the difference between these two numbers. So then subtract the 3, distribute the 3, and then the minus sign. We're going to do it both at the same time. So if you have parentheses, a minus for a minus number value that's being distributed, you need to distribute the minus sign along with whatever is being whatever is outside the set of parentheses. We're going to distribute both the minus and the 3 to the 2 and 3 inside parentheses. So this 2x just comes down. Nothing's happened to him yet. And so minus 3 times 2x is minus 6x. And then times minus 3, negative times a negative is a positive, 9. Down this plus 4. Nothing happened to him yet. He's in parentheses, so he just comes down. All that is equal to 33. Now, we've got like terms to combine. I've got a 2x and a minus 6x. I have a plus 9 and a plus 4 constant number. So I simplify before I solve. So 2x minus 6x gives minus 4x. Plus 4 is 13. And this 33 has been very patient over here on the right side. So he just continues to be brought down. We've got one x term. We've got a simplified expression on the left side. We can start solving now for the variable. And what's being added by subtracting 13 from both sides of the equation. And that gives us minus 4x is equal to 20. X by divide by minus 4, that coefficient of x that's being multiplied to x. X is equal to, pay attention to signs, you've got a positive number divided by negative, so my result is going to be negative 5. Okay, so your signs. Into equations with fractions. Yay! Everybody loves fractions. Well, probably not. So I'm going to teach you how to solve these without really dealing with fractions, okay? Because we can eliminate these fractions before we ever start solving for x. Now, if you solve for x and keep the fractions, absolutely. You can start by subtracting 1/2 from both sides of the equation, which means you're going to have to find a common denominator, and then getting rid of the coefficient 2/7. Now, if you really, 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 really love fractions and operating with fractions, go right ahead. That's just fine. You should end up with the correct solution if you do that correctly. And awesome. If you don't like fractions, let's just get rid of them. Now, how do we do that? Let's look at our denominators. Multiply each side. Remember my scale that I showed you? Whatever we do to one side and do it to both sides, it should keep the scale in balance. We can do whatever we want to eat it as long as we do it to both sides of the equation. So look at the denominators and figure out the least common multiple of our denominators, okay? The least common multiple of 7, 2, and 14. Well, it would be 14 because 14 is a factor of 14, 2 is a factor of 14, and 7 is a factor of 14. In other words, 14 is a multiple of all these numbers. 2 times gives me 14, and 14 times 1 gives me 14. So, if I multiply both sides of my equation by 14, it should get rid of my denominators. Now you've got two terms. Remember, both sides, meaning that whole side gets multiplied by 14. That means 14 is multiplied to my 2/7 x. 14 is also multiplied to my 1/2 because that's multiplying the whole side by 14. That's going to give me 3/14 times 15. Multiply fractions. You multiply straight across. However, we change our 14 to be in fraction form. And that 14 times 2 is 20, divided by 7 is giving me 4. Another way to look at it is I could simplify this first, because a factor of both 11 and 14. So that leaves me just with 2 over 1 times 2 over 1, which gives me 4x. Same with 14 over 1 times 1/2. The 2, 1, and that becomes 7. 7 times 1 over 1 times 1, or plus 7, plus 7. And then apply 13/14 by 14 over 1. These can out. So I'm left just with 13 times 1 over 1 times 1, or 13. So multiply both sides by the least common multiple of all of your denominator values. It eliminates all of your fractions. Because it's a multiple of the denominator will cancel out or become 1. Any number over 1 just gives you whole numbers. So now we can solve this equation as usual. Subtracting 7 from both sides, that's going to get 4x is equal to 6. Then I divide by 4. And so it is 6. But always, when your answer is a fraction, remember to express that in the simplest form possible. 2 is a factor of both 6 and 4. So I need to simplify that fraction to be 3 halves. Okay, solving with fractions. If you want it and solve as usual and just deal with the fractions correctly, that will give you the same result if you don't just eliminate them. Now, eliminating the fractions, you have something that looks like this. 1, look at your denominators and find the least common multiple of denominators. The least common multiple of 6 and 5 is 30. So do is multiply this by 30, the left side by 30, the right side I'm going to multiply by 30. This just 30 times this fraction, x minus 5 in the numerator, over 6. Distribute this 30 to 1, or 30, over 5 times 30. So back over to the left side and see what that looks like. The 6 is a factor of both 6 and 30. I can out. Now we've got nothing but 1 to the denominator. So this becomes just 5 times the numerator. Remember, put your numerator in parentheses because it's 5 times the entire numerator over here. Equal to 30. We've already multiplied 30 times 1 minus over x over 5 times 30 over 1. 5 factor of both 5 and 30. So we got 1 times 1 the denominator, so the denominator goes away. X times 6, or x. Now we've got no fractions. Yay! All we got to do is simplify the left by distributing the 5 to both the x and 5. 5 times 5 is minus 25. 30 minus 6x. Usual. We're going to get rid of this minus 6x by adding 6x to both sides. And that 11x on the left, minus 5, 3. Run the screen here. Get rid of the minus 25 by adding 25 to both sides. Let's bring it here. 11x is 55. this is working out so very nicely because when you divide both sides by 11 to get rid of that coefficient, you're going to end up with x is equal to 5. If you check your work, go back up here and substitute 5 in place, and you should balance the equation. Your fraction. Okay? Now we got two big, I call them chunky fractions because they've got numerous terms in the numerator, so it makes them look kind of large. You still have single values in the denominator. So we, again, will multiply both sides, or every term on the left side is going to get multiplied the least common multiple of all the denominators, of 5, 3, and 15. The least common multiple is going to be 15. So I'm going to multiply every term left by 15. Let me just squish it in here. And then the entire ride, which is only one term, gets multiplied by 15. So it gets multiplied by 15. Can cancel the 5 out of this 15, leaving just 3 times the numerator, plus 6. We can cancel this 3 with the 15, leave times the numerator in this fraction, becomes in the denominator. The 15 will cancel and with the 15 in the numerator, leaving just 28 over 1, or 28. Amplify before solving. Distribute the 3 to both the 2 and the 4x. 3 times 2 is 6. So x is 12x plus distribute to the 3 and to the minus x by 15. Minus x is minus 5x, 28. Woo, a lot of work so far if you've gotten to this point. Now we just have to combine like terms. First, combine these x terms. 12x and 5x gives me a 7x. Positive 6 and positive 15 gives me positive 21. I hope this works nicely. Yes, it is going to work out beautifully. So now you've got a simple equation. 2 steps. Subtract 21 from both sides. That means 7x is equal to 7. And it's a bit nicer than that because I know when I divide any number by itself, I mean x is equal to 1. Equations, you don't like them? It's fine. Just eliminate them by multiplying by the least common denominator, the least common multiple of all the values in your denominators. Okay, remember, when you multiply both sides, that means every term on each side gets multiplied by each common multiple. Now switch gears and talk about equations with decimals. Once again, just like fractions, you can choose to just, as usual, when you working with decimals. However, I don't really care for decimals any more than I care. All right, my phone. Are y'all still hearing me? I can. All right, thank you. Something weird just happened to my phone. You can go and solve as usual, or you can choose to get rid of your decimals. And I really don't care to work with decimals. So because every term is in tenths, and to eliminate the decimal, I'm going to multiply both sides of my equation by 10. My terms, my constant numbers, are represented as tenths. So this is going to get rid of my decimals. So when you multiply both sides by 10, it's going to eliminate your decimals. Change the value of x because you've done the same thing to both sides. And so it keeps your equation balanced. So you have 6x minus 53 is 9. This equation, we're going to add 53 to both sides. 6x equals 72. Sides by 6, and so is equal to 12. If you don't like fractions, get rid of them. If you don't like decimals, get rid of them. Here's an equation where we've got two different decimals, but one's hundredths and is in tenths. Well, if you're going to get rid of your decimals, you have to multiply by the one that's expressed in the smallest place. So since the 0.5 is in hundredths, I multiply both sides of my equation by 100. 100. Notice, if you're going to get rid of your decimal, the 100 only gets multiplied to the 0.25. It does apply to what's in this inside set of parentheses. Now, why is that? This 0.5 is going to be multiplied to the x in the minus 6. If you multiply every term by 100, that means that the 0.5 will get multiplied by 100, and then this will get multiplied by 100, but then when you distribute the 0.25 to the x into the minus 6 or to the x and minus 600, it's multiplied by 100 again. So we multiply these two by 100 twice. So we need to multiply the 100 to this decimal, so eventually it's going to be distributed to what's inside of parentheses anyway. So that multiplying the coefficient by 100 is going to be sufficient for me to get through the set of parentheses. Since when we multiply the 2 by 100 gives me 30x plus 100 because we distribute this 100 to these terms. Now I have any decimals to deal with, and we can solve as usual. Now distribute the 25, which by the way has already multiplied to the 100 when we eliminated the decimal. So that's 5x minus 150 x plus 100. Now, let's just subtract 25x. Let's just do it this way. We'll get 25x instead of getting rid of the 30x. That leaves me with minus 150 on the left is x plus 100 on the right. Solving for x, we subtract 100 from both sides. And then minus 250 on the left is equal to 5x on the right. Divided by 5, negative divided by positive is going to give me a negative 50 on the left, and that x is equal to. So x is equal to negative 50. You can get this answer whether you choose to eliminate the decimals or you just want to straight out just go ahead and work with the decimals. You end up with x is equal to 50. Okay, now special cases. Now I'll show you here in a minute why this is a special case. Let's just start solving. Distribute the 2 to both terms inside the parentheses. The left side is already simplified. So plus 1 is equal to 2x minus 6. Now terms with variables, so let's subtract 2x from both sides to get rid of one of the variable terms, but look what happens. When both of them disappear. So to negative 6. We'll know that 1 is not equal to negative 6. So this is a false statement. You solve an equation that gives you a false result. 1 is equal to negative 6. 8 is equal to 20. 14 is equal to -2. That's a false statement. Therefore, there are no solutions for x that will make this statement true. So values that we place put in place of x that make this equation true. So this equation has no solution. Our special case for x. Again, let's simplify the expressions on the left and on the right by distributing 3 to the 4x, which is 12x, 3 to 24, and that becomes 6x or 12x, and then times 12 is plus 20, 28, that's actually 24. 12 gives me 24. Now, I have the same thing on the left and the right. Just continue to solve by getting rid of one of our x terms. Y special case. Again, both of these x terms disappear. So I'm left with 24 is equal to 24. Now, it's indeed equal to 24. I have a true statement. So this equation, 3 times 4x 8 is equal to 2 times 6x plus 12. That means that all solutions for x, any value that you want to put in place of x in this equation will make this equation true. So anything. X could be 4, x could be 0, it could be negative 5,428, and it's still going to give you an equal or a true statement. So this special case, when you end up by solving, you end with something that's true. Know that all solutions that you want to place in place of x will work in this equation. So end up with a false statement, there's a solution for x. When you with a true statement, all solutions for x will work. So before we call it a night, I know it's a long session. Thanks for hanging in there with me. Solving equations and formulas, literal equations and formulas. That's when you've got more than one variable and you're asked to solve for a specific variable. Hint, hint, hint. And this is where it's really going to take discipline. You need to keep your eye on the target variable. Well, what's the target variable? What you're asked to solve for. So I got C is equal to 2 pi r, which happens to be the formula for the circumference of a circle. Circumference is equal to twice the radius times pi. Asked to solve for the radius here. So we need to keep our eye on this target variable and undo the same way we've been doing, undo what's being done to target variable. In other words, we need to solve for r. We equal to something. Let's look at what's happening to r. Well, all of these are multiplication. By pi and 2. Highlighting r by pi and 2. We by 2 and pi. Pi and 2 and pi. But what we do to one side, we have to do to the other. So the circumference divided by 2 times pi is equal to r. R is equal to c pi. The same process for solving equations with one variable works for solving equations and formulas with more than one variable. Look at this. D is equal to 1/5 V times Z to solve for V. So we need to keep our eye on this target variable. V is being multiplied by Z and multiplied by 1/5. Well, because of fraction, let's take this one at a time, okay? So let's get rid of this 1/5. When it's being multiplied by 1/5, how do you undo multiplying by 1/5? Well, you would divide by 1/5 to get rid of it. For dividing fractions, that's the same as changing division to multiplying by the inverse. So really, to get rid of dividing by 1/5, we multiply both sides by 5. And so multiply to this 1/5 and give us 1. So now we've got 5d on the left is 2d times the d. Step, we see that v is, again, keep your eye on d. We're undoing what's being done to v. What's being done to v is it's being multiplied by z. So we've got to undo that by dividing both sides by z. So we've got 5d over v equal to, these become 1. So v is equal to 5d over d. All right, it's there when you see all these, the steps are the same. You simply have to undo what's being done to that variable. Now we're asked to solve what is equal to 2x plus 5 for the variable x. So x is our target variable. We undo what's being done to x. Well, we're not. So first thing I do is subtract 5 from both sides. Give me y minus 5 on the is equal to x. Got to get rid of the 2 by dividing sides by 2. You're dividing both sides by 2, but it's really, you're dividing by 2 in both terms by 2. Then you're going to end up with y over 2 minus 5 over 2 is equal to x. This is a perfectly acceptable answer for now. And we'll bet that y over 5 is the same as 1/2 times y, or 1/2 y. So either way you want to write this answer is correct. Okay. This is probably the perfect way so that we can see the coefficient of our variable y. One more and then we'll be done. Now we want to solve for y. 3x plus 5y is equal to 20. Being done to my y variable. Well, we need to get rid of this 3x by subtracting 3x from both sides. With 5y on the left is a minus 3x plus 20, or 3x. It doesn't matter for linear equations, because this is a linear equation. You pretty much want to express x term first. Solving for y by dividing everybody by 5. Everybody gets divided by 5. And with just y, that our goal is equal to 3x over 5, or negative 3/5 times x, plus divided by 5 is 4. So you always want to, when you got fractions involved, you always want to simplify your fractions, express that simplified version as your final answer. All I have, and I went a little bit beyond our 45-minute time period. We've got 2 webinars coming up, one on the 21st of March and one on the 18th of March. I hope that you guys will be in attendance, and I hope